so this is a base 2. How do I make this a base 2? 1 over 4 is 2 to the negative what? 2 to the negative 2. You have to make it be a base 2. So we have y equals 3 times 2 to the negative 2, x plus 3 minus 6. Now some people will insert that negative 2 in. Is it helpful to put the negative 2 in? Or do we have to have a 1 in front of our x to state our transformations? Yeah, so if you want to rewrite it, you could rewrite it like this, but you have to keep that 2 negative, oh, sorry. So most often they are base 2 and base 2, right? Most often it's a base 2 and then I give you a transformation of a base 2. That's an easy one. What I want you to do is, what if I don't give you a base 2 and a base 2? You have to make that second one be a base 2. You can only compare them if they have the same base. Now can we compare them? Base 2. Base 2. Can I compare them now? Yes, they're both increasing exponential functions, base 2. Increasing is when b is greater than 1, right? So state all the transformations. The only thing that should not appear on there anywhere is that 2. Write out your transformations and your mapping. So our transformations, we're going from y equals 2 to the x to that one. So we have a vertical stretch. Which order do we have to go in every time? Search. Stretch, reflect, translate. So we have a vertical translation. Oh my gosh. Vertical stretch. I say certain, then start with translate. Vertical stretch by a factor of what? Of 3 above b. X-axis. Is there a horizontal stretch? Yeah. So no flipping y's, but the x's do. So we have a horizontal stretch by a factor of what? Of 1/2 above the y-axis. Are there any reflections? Yeah, it's with the, there's a negative with the x, so it's a reflection in the y-axis. Vertical translation 6 what? Down. And a horizontal translation. Units what? So mapping in words are in a heart. So the flipped x's that we use, we have to use in mapping, right? So we have x, y, you're no flipping y's. So we get our x is going to be negative 1/2 x minus 3, and our y is going to be 3y minus 6. The y should never be wrong because they're always the same. Okay, exponential graphs. Let's think about an exponential graph. Exponential graphs have a horizontal or vertical asymptote? Horizontal. Because remember, exponential graphs look like this. They either look like this, and they look like this if they're doing what? Growing. So b is greater than 1. And then if they're this way, what is b? Between 0 and 1. You can't have a negative b if you're talking about word problems, right? Between 0 and 1, think about it. If b is 1, it's neither increasing nor decreasing. It's just 100% of what it was. If b is greater than 1, it's increasing past 100%. If b is between 0 and 1, it's decreasing by that much. So if b was 0.97, 0.97, how much would it be decreasing by? If b was 0.97, how much would it be decreasing by? 0.03. It's just how far it is away from 1. If it's a half, if B is a half, how much is it decreasing by? 50% or a half, because that's how far away it is from 1, right? If my B is 0.80, what's it decreasing by? 0.20, which is 20%. It's how far away it is from 1. If I give you 1.20, what's it doing? Increasing by 0.20. It's how far away it is from 1. So if it's below 1, it's how far away below it's decreasing, how far it is above increasing. So that's when B is 2, it's increasing by 200. It'd be 200%, so it would be doubling, right? Because it would normally be a 1. When it's a 2, it's 100 to 200, so it doubles. All right, so this is normally where my exponential graph looks like. That's what it normally looks like, correct? So what is my domain always? Well, that's a word problem, technically. X and M of the reals in set notation, or in interval notation. The intervals it's between are negative infinity, positive infinity. Now, exponential graphs normally have a horizontal asymptote on the x-axis. What's the equation of the x-axis? Y equals 0. What's the only thing that can move a y? Vertical translation. So my vertical translation is my asymptote. Remember on exponentials? On exponential graphs, my vertical asymptote is y equals my vertical translation, because it's normally at 0, so if it's not at 0, that's my vertical translation. Bless you. And this one moved 6 down, did it not? So this one has a vertical asymptote at y equals -6. Now what makes it greater than -6 or less than -6? A reflection in the x-axis. Is there a reflection in the x-axis? Is there a reflection with the y? No, there's no reflection with the y. So what's my range going to be? Greater than -6. If they give you variables, could you plug in values for them? Like if they say A is greater than 2 and B is greater than 3, let's say. Could I plug in values? Yes. But the answer's still going to have to be in A's and B's. You can't just put like 2's and 3's because you changed it. Okay. Oh, horizontal. Typo. Verticals on logs. Yeah. Oops, horizontal. Ooh. And so it's greater than -6, so it's round bracket -6 to infinity. Now logs have a what type of asymptote? Vertical asymptote, and it normally sits on the y-axis, which is the equation of x equals 0. What's the only thing that can move an x equals 0 line? Horizontal translation. So my vertical asymptote on a log, this one's vertical, is x equals the horizontal translation. So remember, logs and exponentials are just inverses of each other, correct? Is that one in a form that I can start doing stuff with? No. No, it needs to be in what? Y equals and? Luke, what'd you say? 1 in front of the x. Is it currently in either of those? No. No. So we need to get y equals negative log base 3 of -2 x minus 3 minus 3. Now I can only compare logs if they have the same base. Do these have the same base this time? Yeah. Does that base appear anywhere in my transformations? No. So I don't have a vertical stretch, but I do have a horizontal stretch. By a factor of a half. About the y-axis. This one I have reflections in both. So I have a reflection, and I can write it, this is the only one I can write together, reflection in the x and y-axis. I have a vertical translation. Three down, and a horizontal translation. 3 units, right. Type this into your calculator. Typey, typey. So when you type it in, does your log look like it stops weirdly? Does your log look like it stops? What do we talk about when it comes to a log? Yeah. It disappears, but it's not actually gone though. Yeah. So it looks like your graph stops, but log graphs are YER. It looks like it stops. If you go to second table and you actually look at the actual table, it's still drawing, right? But remember with logs, for some unknown reason, your calculator has a computer glitch in the fact that it just can't draw it closer to the y-axis, and I don't know why. It literally looks like it stops, but it doesn't stop. It's YER. And if you went second table, you'll see that it actually keeps going below those. It gives you an x and a y value below that y value. Okay? It keeps going even though it looks like it stops. We agree? So my range then for log graphs is y such that y is an element of the reals. And why is that? Because logs and exponentials are inverses of each other, and an exponential is XER. So a log is YER, right? My mapping, my x switches, my y stay the same on from the equation, or mapping and words are the same. So I get negative 1/2 x plus 3, comma negative y minus 3.
Why in my calculator in the table it still just says error?
In the x's or the y's? It's erroring to a certain point, but it won't keep erroring.
Like all errors.
You guys, there's no graph after 1 and 0. It looks like, but it's just because it's getting so close that. Okay, let me show you. What is the domain of this one? It's because you guys are literally, there is no graph on on that x, but there still is on the y. It's because after that asymptote, there's no graph, but the graph gets closer. I'll show you. What is the actual asymptote of this one? Asymptote. Vertical asymptote is x equals 3, the horizontal translation. We agree? And what's your domain? X such that x is less than 3, x an element of the reals. So when you go to 4, is there going to be a y value that goes with it? When you go to 4? No. When you go to 5? No. When you go to 6? No. When you go to 7? Did you see that your table of values is actually conducive to x values, not y values? Right? It goes incrementally by x's. It doesn't go incrementally by y's. So let's try this. We want to know up to 3 if my y's stop. We agree? So in your table, you go second trace, and then it gives you 2, 3, 4, 5, 6, 7, error, error, error. The graph's not there, right? But we can check really close x's 2, 3, How do we do that? We do second trace value. So type it in. Second trace value. We can't put, if you put it, go second trace value 3. Put in the 3. What happens? Y equals nothing. It's an error because it has to be less than 3. We agree? So we kick that one out. What about if I do 2.9? Second trace value 2.9. What do I get for a Y? No, can't see. So when you put in 2.9, you get negative 5.350000. Okay? Now put in second trace value 2.99, because that's really close to 3, right? Second trace value 2.99. What do we get? 0.560878, right? Then second trace value, put in 2.99999. 4.7. Wow, the graph's still there. It just says you can't see it. You put in 2.9999, it draws a point on your graph, but it doesn't let it draw the point. I don't know why. Put in one that's even closer, 2.999999. That's extremely close to 3, but not 3. Does the graph still exist? There's a really high Y value, right? But it doesn't look like it's being drawn, does it? Because it's not being drawn. Your calculator has an issue. The graph is still there, but your calculator fights drawing it. And I don't know why. Does that make sense? So you're getting closer and closer up to that 3. The problem with your table of values is it is increasing x incrementally. So 2 good, 3 bad. It's like, I don't know, I feel like it becomes 2 good, 3 bad, big man or something. But, yeah. But then there's a whole bunch of x values between 2 and 3, is there not? Your table of values doesn't show them. So remember that your log graph, although it looks like it cuts off, is YER. YER, the exponential is XER, the log is YER. They are inverses of each other. It cannot be anything different. That's how they work. All right. We're going to skip this one. We're going to go down to this one. So, how do you determine the asymptote on an exponential graph? Yeah. So, exponential normally sits here. It's a horizontal asymptote. It's a horizontal asymptote it's on the x-axis, so it's y equals a number. How do we get that number? What can move a y equals line? Nope. A reflection would make it the same, yeah. Vertical translation. So our horizontal asymptote is that y equals the vertical translation. The only thing that can move it off that 0. Log graph is normally on the y-axis. It's a vertical asymptote at x equals 0 because the equation of the y-axis is actually x equals 0. What's the only thing that can move that? Horizontal translation. So your vertical asymptote is that x equals the horizontal translation. So that's all about logs and exponential graphs. Then we're going to flip over and do radicals. So on the top it says the parent function y equals root x starts at 0, 0 and goes up and to the right. Correct? Your normal radical graph goes up and to the right. It's 0, 0, 1, 1, 4, 2, 9, 3, and it's up and to the right. That's what the parent function of root x is. Zero, 0, 1, 1, 4, 2, 9, 3. And that's what it does, right? That's your normal y equals root x. So if it's not up and to the right, we have a reflection. We talked about that, correct? If it's to the left, we have a reflection in the y-axis. If it's down, we have a reflection in the x-axis. We've talked about all those things. Radical equations are amazing as the starting point of the transformed graph gives you the horizontal and vertical translations immediately. Because it starts at 0, 0, if I go to look at an actual graph, if it's not starting at 0, 0, I have a horizontal and vertical translations wherever it is. That's the great thing about a basic radical graph. But we're going to compare these two. So I want you to give me the transformations, mapping, domain, and range. Now, if the basic function is like this, my domain or range is going to be x is greater than or equal to or less than or equal to a certain value. Why is it equal to? Same with range. Why are these ones equal to and the other ones aren't? This is 0, 0, and there's no what on this graph. Starts with an A, rhymes with asymptote. Oh, it's asymptote, yeah. So if there's an asymptote, it can't equal it, because that's where the dashed line exists. So the graph is either greater or less than asymptotes, correct? A radical graph doesn't have an asymptote. It just starts at a certain spot because you can take the square root of 0 and any positive number. So that's why the graph starts at a spot and then like curves up or curves down, because there's x values that would create a negative under the square root, so we can't use those ones. Okay? So I need you to get this into what first before we can state transformations? Y equals and a 1 in front of the x. Positive 1 in front of the x. So this is the first lesson where I gave you a radical and then asked you to give me transformations of it. Radical to a radical, right? Radical parent function to a radical parent function, or radical function up here. Remember that when you divide by a negative, the number gets bigger, right? Not a negative, sorry, a fraction, the number gets bigger. If you don't remember that, you guys, your calculator will do it for you. You can go 6 divided by negative a half, and it'll tell you it's negative 12, right? So my domain is either going to be greater than or equal to or less than or equal to 12. And my range is either going to be greater than or equal to or less than or equal to negative 4. Because the only thing that can move you off of 0, 0 are translations, right? So I know my domain is going to be based off the 12, and my range is going to be based off the negative 4. That I very much know. I also know it's equal to because it's a radical. It's not an asymptote. Asymptotes are greater than or less than, but not equal to, right? Now, my domain here is going to be x such that x is something 12. Now, is there a reflection with my x? Yeah, there's a reflection with my x value, right? So that means there's a reflection in the y-axis. So instead of up and to the right, it's now going to be up and to the left. So it causes the inequality sign to flip, right? So we're going to get less than or equal to 12. X is an element of the reals. Negative infinity to 12. Remember, you can type them in and try and look at them as well. They'll often put in variables, but you can try and put in some numbers to try and see it. The range, is there a reflection in with my y value in my equation? No, so there's no reflection in the x-axis. So it's still up. It's still going up, right? So my range is going to be y such that y is something -4. It's still up. It just happens to be to the left. So it's up and to the left. So it's going to still be greater than or equal to -4. X is an element. That's not an x. Y is an element of the real. Now, I want you to determine the equation of the graph below. We're going to do this one first. Remember, as long as I get the h and the k filled in, I can use any point off of the graph to find a. Correct? That's how we always find a. That's the easiest way to find a. If you're missing a, you fill in everything but a, the vertical stretch, and you plug in a point, an x, y off the graph, poof, you have your a. Correct? So, how do I get my h and my k? Remember, from a radical graph, it's the easiest. How do you get your h and your k? Yeah, how far away it is from the origin. Because the only thing that can move us off of 0, 0, which is where we were, are horizontal translations, vertical translations. Because if I multiply 0 by a stretch or a reflection, it stays 0, correct? That's a great thing about radical equations. They start at 0, 0. Radical graphs, the parent function, so the only thing that can move it is horizontal vertical translations. So we actually moved 6 left. And what did we do? It's up and to the right still. So are there any reflections? I better not have any reflections. It's up and to the right. If it's to the left, you're going to end up with a reflection with the x value. If it's down, you're going to end up with a reflection with the y value, right? So it's reflection in the x or reflection in the y-axis. So I know this is going to be y equals a root x plus 6 minus 2. How do I find my a value? Yeah, I'm going to use 3 and 1. They'll often bold something if it's a diploma because they'll want to pull you to one specific coordinate, so everyone does the same one. So if something is bolded, like that blue one is bolded, that's a hint, use it, okay? If you have a bolded point on your graph, they're bolding it for a reason, not just because they randomly want to bold something. So this is 3, 1. So that's my x and my y. So I get 1 equals a square root 3 plus 6 minus 2. 1 equals a square root 9 minus 2. Add my 2 over. And I get 3 equals a times 3. Divide by 3. A equals 1. So I get y equals 1 root x plus 6 minus 2. Didn't realize the pictograph that gave me 1. This backfires for proving the b part. So, for the b equation, it would still be 1, which is stupid. So I'm going to give you a different example right below it. So say I give you, this is like a caveat. Say my a value when I find it is a 2, so or a 4. So I'm going to say this is, pretend this is the graph. This is an equation. And I want to transform it to, they want a horizontal stretch. Cool, I have a vertical one. Awesome. They want a horizontal. Remember, radicals are one of those that you can move in and you can move out, right? How do I get this to go inside here? Because I need it to be a horizontal. Square it, right? Not square root. Take it out of the root, square root it, take it back in, square it. This is why you guys did mixed radicals and entire radicals in grade 10 over and over and over for a week. You just made them all inside, then you took them back out, then you brought them back in, then you took them back out. Why? For the quadratic formula to reduce a radical. Why? So that you can bring back in your horizontal stretch. You guys were preparing. Everything you did in grade 10 gets used in 12. Everything. Except for trig. Little triangle. Actually, that sometimes does too in our trig because you have to be able to do Pythagorean theorem. Everything in grade 10 gets used. So I wish I could just like really make the grade 10s believe that in grade 10. So we have y equals square root. The 4 comes in, it becomes a 16. and we leave our brackets because we want to have a 1 in front of our x. So either they can say I have a vertical stretch by a factor of 4 about the x-axis, or they could say I have a horizontal stretch by a factor of 1/16 about the y-axis. And people will say, but what if they have both? They can't. Those are both correct answers. They can't be like, which is the best? There's no such thing as best. They're both right. So they either would have to put that one or that one. They can't put both. They're both correct. You type both of them in, you get the graph. So they can't do that. People think you're being tricky. That's not tricky. That's just totally incorrect. You can't give two correct answers and pick one. Okay? So they have to give one or the other. So how might they do it? I would say when you put it back in, put a 2 here. Because some people will put the 4 in and square root it instead of squaring it. Right? And then I would use a horizontal stretch by 2 or a horizontal stretch by half, which are both incorrect, or a vertical stretch by 16, or sorry, a horizontal stretch by 16, which is also incorrect. You can find numerous ways that you guys can make oopsies. Right? Okay. So that was the first lesson. The first lesson in radicals was I gave you a radical, I transformed the radical, you gave me information about the radical. Right? Lesson 2, very different, not the same, completely different. Completely different. I give you a function. I tell you to square root the entire thing. I give you a function. I tell you to square root the whole thing. There's nothing outside of the radical at all. It's all under it. Two totally different lessons. One is I gave you a radical, transform a radical. Correct? Second lesson was I give you a function, tell you to root the whole function. Entire thing. Where do invariant points happen when you square root? What y values never change? 0 and 1. So only for this lesson, you guys will get it mixed up. You'll say, oh, the invariant points on when I go from one transformed radical to another is 1 and 0. No, it's not. This only happens when you square root the entire function. And why? Because you're mapping, when I tell you to take the square root of an entire function, your mapping is xy becomes x what? Square root y. That's all you're doing. This literal lesson is all y becomes x root y. Your x's stay the same, your y's get all rooted. Why do your y's get rooted? Because what is f of x? Just a fancy way of saying y. Square root all your y's. Square root all your y's. That's all it's saying. Don't do anything to your x's. Root all your y's. Right? So, if they give you an equation, can you not just type square root 3x minus 1 into your calculator? Yep. Type it in. Invariant points are points that do not change, correct? So I want the ones when y equals 0 and y equals 1. We agree? So you have this into your calculator now? Right? Okay. I want the invariant points. We're going to do that first. We'll do it algebraically after, but I want to do it graphically first. So if they ask you to find the invariant points and don't specify how, graphically you can go y equals, into your y2, put in y2 equals 0. So leave your equation in your y1. And in your y2, put in 0. Then what are you going to do? You're going to look for where they what? Intersect. Second trace 5, enter, enter, enter. And you should get 0.333333333333. Is that what you're getting? Are you getting 0.33333? You should be. y2 equals 0. This is your y1. It's occurring at the x-intercept, which is 1/3. Second trace 5, enter, enter, enter. Could I have just put this one in and put in y2 equals 0? Yeah, the point doesn't change on either one. So you could put the original in and put y2 equals 0. So it's going to be at 1/3 and 0. And then y2, what are you going to change your y2 for the other invariant point? 1. Take out 0 and now put in 1. Second trace 5, enter, enter, enter. This one I don't. Oh. 2/3? Do you have to type the square root 1 in? Could you type the original 1 in and still do 0 and 1? Yes, for some of you that will be easier, especially the TIU3s, because they fight all the world and a lot of things. Invariant points means between the original and the square root, that will stay the same, right? So I could put in the original or I could put in the square root, y equals 0, find them, y equals 1, find them. Okay? So I want you to find the invariant points with this one. Type this one in. So you can either type in this, or you could type in this. Invariant points don't change. So you can put in either one. It doesn't matter. But graphically, we're going to do y2 equals 0. And this one's going to get me 2. Why is this going to get me 2 invariant points? It's a quadratic and there's 2 x-intercepts. And then you're going to do y2 equals 1, and this one gets me 2 as well. You have to intersect twice for the 0 and then twice for the y equals 1. Remember, when the y equals 0, you can make your line thicker if you want to. So it's literally just finding out where they intersect with your calculator, with y equals 0 and y equals 1. The 0 ones are extremely important because they're going to be what gets you your domain. Yeah. If you put in the root, it sometimes will fight you. Type in the original, don't type in the root. Sometimes the root fights you. So if you want to type in this one, it's easier. Which is what I always do. Don't type in that. Type in 0 or 1. So you either type in this equation or this one. I prefer this one. Why do I prefer this one? Because it literally looks like this. So when it crosses, it's a lot easier for it to find the intersections, correct? If you use like the original. Because you can use the original or you can use a radical. It's where it intersects at 0 and 1. This one is completely concave down, so I don't know why I just drew that graph. It would be like this. Okay. So this graph here, if we look at it, this graph here, the original, is at -1, then up 3, right 1. So this graph looks like this. We agree? When I find the square root of it, or you type the square root in, this part's gone, is it not? The whole bottom part? It just starts at where? What is that called? The x-intercept. So your domain is going to be based off your x-intercept. And what was your x-intercept? 1/3 and 0. We found it because it's an invariant point. And then these are going to drop and it's going to go like this. Correct? So what is my domain then? X such that x is greater than or equal to, because it's a radical, not an asymptote, 1/3. So your x-intercepts are extremely important to get your domain correct. What's the range of this graph? Where is it starting at? Y equals what? Where's the radical graph starting at? 0. All the negative y's go away. You can't draw those, right? Square root of -4 doesn't happen. So your range is going to be y such that y is greater than or equal to 0. Now the other graph you have here, this will stay, this will stay, this will stay, this will stay, 0.5 goes up a little, 0.5 goes up a little, and then if this is a, whatever it is, it'll drop down, correct? So what's my domain between? The x-intercepts, is it not? And we found our x-intercepts. What were they? -4 and 1. They're right here. So my domain, if it does the bubble, this concave down will be in between, is x such that you have to do loser loser. You have to go from low to high. So -4 is less than or equal to x, is less than or equal to 1, x and m are the reals. What's my range though? What's my lowest y on that graph? On the radical graph? 0. And where's my highest y? Can you not type the graph in and find the maximum? Yeah? Of the radical or of the original? Yeah. So it'd be a square root of that, right? If you want the maximum of the radical, you type the radical in. And then you can find its maximum. So it's between 0 and 2.5. Y such that 0 is less than or equal to y is less than or equal to 2.5. Some people are like, how did you get 2.5? I just found the maximum of the radical graph. Like I just typed the radical graph in. So I can either give you an equation and ask you for the square root of the equation, the domain, the range, the invariant points, right? Or instead of giving you an equation, which you could just type in and look at, right? The other option they can give you is they can give you two graphs. Look, they gave them to you. I didn't give you the equation, correct? So you have to sketch them from here. How do you sketch a radical graph? They're easy. How do you sketch it when you take the square root of a whole function? So see here, g of x equals the square root of f of x, and these are both f of x. So how do you do that for mapping wise? xy becomes x root y. So I start on this one here, if I want to. This is going to be at -2, 4. It's going to become -2 root 4, which is -2, 2. I could do -3, 5. I could go sequentially instead of randomly like I'm doing here, which is -3 and root 5, which is going to be a decimal. So it's going to be negative 3 and 2.24. I don't know, somewhere like there. I could do negative 1 and 3. It's going to become negative 1 and root 3. 1.73. Zero 2 becomes 0 and root 2. 1.14. Sorry, 1.41 I mean. 1 is going to remain 1 because 1 root 1 is 1, right? 1.4 and I draw at 0.4. Let's give myself some. Oh boy. Negative 1 and 1.73. 0 and 1.4. 1 and 1. This one remains invariant, remember? These stay variant. And then 0.5 you just draw a little above because it goes outside of it at 0.7. And you get this graph. Can I just draw the arrow randomly forever, however I want when I don't have any more points? I can just shift it off for life? No, I stop at where I'm accurately drawing and I put an arrow on the end of it, right? So my domain for this one is x such that x is less than or equal to 2. X is the noun of the reals. My range is y such that y is greater than or equal to 0. My invariant points label would be like this and like this. Invariant points. Why did I stop at 2, 0? Why didn't I draw more? Yeah, so if I go 3, negative 1, that's going to be 3 square root of negative 1. Uh-oh, that gets me nothing. That's not possible. So all the negatives go away. This one here, I'm just doing this quickly. It'd be here and here. It would remain invariant because where it's 0 and 1, it's invariant. So red, bold, invariant points. The lines go away. 0.5 goes a little higher. 0.7. 16 is going to drop down to 4. Right? Wherever we have 4 is going to drop down to 2. So that's going to go here. This is a 4. It's going to drop down to 2 here. Oh, that's not 1. Come on, Lepp. It's a scale of 2. Rebound. 0. Red dot. 0. 1 would be here. These would be the invariants. And 0.5. Scale of 2 really messed me up. 4 drops down to 2. 4 drops down to 2. 9 would drop down to 3. Remember, you do that raining down. 9 would drop down to 3. And we could get way more points in there, couldn't we? If we wanted to. My domain, when it's sandwiched, is x such that negative 2 is less than or equal to x is less than or equal to 6. If it's not sandwiched, you have to write an or in between. You'd have to say x is less than or equal to negative 2, or x is greater than or equal to 6 if the arms are going out, right? If it's not sandwiched in between. And my range, this one is sandwiched between 0 and 4. Y such that 0 is less than or equal to y is less than or equal to 4. Okay, then we're flipping over to rationals. if I give you rational graphs, first thing you're always going to have to do is factor. Remember, if they cancel off, there's a point of discontinuity. If they don't cancel off, there's not. So this one's full fraction over full fraction, so I have to use full fraction rules. So I'm going to get -2 over x minus 5, x plus 1. Anything cancel? What are my NPVs? 5 and -1. If they don't cancel, they're both vertical asymptotes. Remember, if they cancel off the points of discontinuity, if NPVs don't cancel, they're vertical asymptotes. So I have a vertical asymptote. At x equals 5 and -1. Since it's a full fraction, I use horizontal asymptote rules, which talks about the degrees. What is the degree of the numerator as opposed to the denominator? The denominator is bigger than the numerator. When that happens, we always get what? Y equals 0 every time. Domain and range are easy. They're just not equal to those, right? So my domain is x such that x can't equal positive 5 and -1. X and L are the reals. My range is y such that y can't equal 0. Y is now in the reals. We're going to skip 2 for a second because it's not a full fraction. It uses different rules. It's in transformed form. So let's look at 3. 3, I have to factor the numerator and the denominator. I'm going to get x plus 2 and x plus 3 in the numerator. And in the denominator, I'm going to get x plus 2 and x minus 1. Wait a second. We have factors that are canceling. What happens when we have factors that cancel? Point of discontinuity. So these cancel off. So I know I have a point of discontinuity. At x equals -2. But it's a point. So it's -2 and something. How do I get to something? Plug it back into the simplified equation. So I'm going to get j of -2 equals -2 plus 3 over -2 minus 1. When you enter the room, it scares me. Oh, who's paying that?
You know what?
You're so awkward.
Here's how I'm gonna say it. I brought a whole bunch of change. I was gonna give you change to pay you back, but then I thought, that's a little rude.
You don't need to write on it. It's just my... No, don't say... Okay. You're on my podcast. Humphrey is stapling a $20 bill to my wall.
Right through the queen's head. No.
This is what happens when you, like, borrow people $20. They pay you
You
back.
borrow people $20?
You lend it. Get out of here.
Word choice is
You're awkward. Get out of the room. All right. When he walks in, I get afraid. Like, I don't know what's going to happen. Is he going to sing happy birthday? Is he going to start clapping? Is he going to staple the queen to my wall? All right. Okay. So we're left with this. When we're left with this, what is that actually? Starts with an R. It's in this unit. It's the title. Rhymes with rational. Rational. I don't have time. Micah, can you answer the phone? Okay. So we get a vertical asymptote. We get a vertical asymptote at x equals 1. That's my secretary now. And we get a horizontal asymptote. Okay. Thank you for that. Good secretary skills. Horizontal asymptote. The horizontal asymptote is at what? So this is what remains. Remember, this is a full fraction. So what's my rule? Degree 1, degree 1. What do I do? Fraction of the coefficients, which happens to be 1 over 1, so this one is also y equals 1. So what you have to watch yourself with this is you have to, when you state the domain, you have to state the domain of it can't equal the x of the discontinuity or the vertical asymptote, right? A lot of people forget about the discontinuity stuff. So my domain is going to be x such that x can't equal 1 or negative 2. You're good to go. X is the noun and the reals. And the range is y such that y cannot equal 1 and negative a third. Y is the noun and the reals. Okay, let's look at this one here. This one here, when I factor it, I get x minus 2, x plus 1, x plus 1. The x plus 1's cancel. What happens? Point discontinuity. What's left over? What is this? Grade 10. It's a line with a point discontinuity. So did I get any asymptotes with this one? No, it's a line with a point of discontinuity, right? Difference between this one, when I canceled it off, I still had a rational left over. Do you see that? This, so I get a vertical and horizontal asymptote. This one here, when I cancel out, I get a line with a point of discontinuity. That's it. So what is my point of discontinuity at? It's at -1, and then I have to solve. So I get g of -1 equals -1 minus 2, which is -3. So when I go to state my domain, it'll just be can equal -1, and my range can equal -3, right? This one here is our last full fraction. There's nothing to factor, nothing cancels off. So it's just a basic rational. Is there a point of discontinuity here? No, so we use rational rules with full fractions. This here gets me my vertical asymptote. 5x minus 2 equals 0, 5x equals 2, x equals 2 over 5. So I have a vertical asymptote. Remember, if the NPV doesn't cancel off, it's a vertical asymptote. So I have a vertical asymptote at x equals x equals 2/5. What's my horizontal asymptote at? 0. Why? Bottom is bigger than the top, so we get y equals 0. Okay, the two that I left are not in full fraction over full fraction, correct? Yep. They're in transformed form. How do we know that? They're not a full fraction. And neither is this one. Just narrowing it down by they're not full fractions, right? So when they're not full fractions, we have to watch ourselves. When they're not full fractions, our NPV is still our vertical asymptote. Cool, doesn't change, right? Still the same thing. That is not what changes. The rules to get your horizontal is what changes. Okay, if they're not in this is transformed form. So my vertical asymptote is at what still? What's my NPV at? It's at x equals what when I solve that out? 3 over 2. This form, you don't need to know the rules if the degree of the numerator is smaller than it's 0, the degree of the numerator and the denominator is the same, so fraction of the coefficients, right? To get your horizontal, it's just your vertical translation. It's this. Your horizontal asymptote. You have been taught this before, I promise. Your horizontal asymptote is at y equals 6. It's way easier than even the previous one. You don't need any rules. So what would your domain be? X can equal 3/2. What would be your range? Y can equal 6, right? So that's for that one. This one, not full fraction either, correct? But what can I do to my numerator? Take out a GCF of 3, and I'm left with x plus 2. Oh, looky here. Things are going to cancel. Things cancel, I get a what?
Point of discontinuity.
Answered correctly. That's what I was going for. It's good. It's good. So I still have left over this. What is this? That's a rational in transformed form, correct? This looks exactly like this did. Now it's exactly that. It's the same thing. So I'm going to deal with the point of discontinuity in a second. I'm going to let that go. I want, what are my asymptotes for this one? Because this didn't cancel, I know I have a vertical asymptote, right? Remember, whatever NPVs don't cancel, they're a vertical asymptote. It's a no-brainer. So this is a vertical asymptote at x equals what?
1.
And then this is a what?
Horizontal.
Yeah, horizontal, yes. Horizontal asymptote at?
4.
Close. Y equals? There's a sign on it.
Negative.
There we go. Keep saying the same answer, eventually Mrs. Lepp will be like, yes, actually you're right.
That's not mine.
Okay. Now, we still need that point of discontinuity, correct? The point of discontinuity is at 2, -2, and what? Well, I have to plug it into here. M of -2, the simplified version. So I get 3, -2 minus 1 minus 4. So I get 3 over -3, which is actually -1 minus 4, which is -5. So don't forget with your domain and range to put the point of discontinuity in it. I can't explain how many people don't. X can't equal 1 and -2. X is an element of the reals. The range. Y such that Y can't equal -4 and -5. Y is an element of the reals. Now, I will do a podcast at the end of the day and post it for this number 3, how to get the equations of rationals. The one thing I didn't go over is adding, subtracting, multiplying, and dividing functions. Remember, the key thing to adding, subtracting, and multiplying of functions is that the domain exists where they both exist, right? You can't add, subtract, or multiply where the graph doesn't exist, right? Because you remember what you do is you keep the x's and just add the y's. We do tables, and we did that. With division, there's a catch. Because with division, you're going to divide by 0, right? So if I gave you, let's say y equals f of x over g of x, or the ugly version of this, which is f of g over x, which means the same thing, you have to watch where, so if this is f, and this is g, the red is g, wherever g crosses the y-axis, what's going to happen? You're going to get a vertical asymptote y. On the x-axis, what is y?
0.
0. So what would g be then? G of x would be 0 there. Can we divide by 0?
No.
No. That's an absolute, like that would get you an asymptote. If the graph did this, which I've seen in some places, if the graph did this, guys, what would happen when you have it crossing at the same spot? That's not an asymptote, that's a what? It'll get you a point of discontinuity, an open dot, because you're going to get 0 over 0. You get 2 factors that would cancel. So with g crosses itself, it's an asymptote. If g and f both cross there, it's point of discontinuity.